Hello everyone, welcome to part 3 of Unit 1. In this section, we will be covering service and compliance level agreements and case study based on open source software platforms for private clouds such as Eucalyptus and OpenNebula. The next topic is based on the book Cloud Computing Principles and Paradigms by Rajkumar Bhaiya. From this book, we will study Chapter 16, which focuses on SLA management in cloud computing from a service provider's perspective. In cloud computing, two important agreements exist between the cloud service provider and the customer. That is, service level agreement called SLA and compliance level agreement called CLA. A service level agreement is a formal agreement that defines the performance and service commitments provided by the cloud service provider. The main purpose of an SLA is to clearly define the expected quality and reliability of cloud services. It includes details such as service availability, uptime, response time, maintenance schedules, and penalties if the provider fails to meet the agreed service level. For example, an SLA may guarantee 99.9% service uptime. A compliance level agreement or CLA focuses on legal and regulatory compliance requirements. It ensures that cloud services follow rules related to data protection, privacy, and industry regulations. A CLA may specify how customer data is stored, processed, encrypted, and protected. So, while SLA mainly focuses on service performance, CLA focuses on compliance and legal requirements. There are mainly two types of service level agreements in cloud computing: infrastructure SLA and application SLA. An infrastructure SLA focuses on the infrastructure provided by the cloud service provider. The provider gives guarantees related to server availability, power, network connectivity, and hardware resources. The customer manages the applications running on the servers. The servers are leased to customers and are isolated from other users. The second type is application SLA. In this model, the cloud service provider is also responsible for supporting the application performance. Resources are allocated dynamically depending on the application's workload and demand. The provider ensures that the required application service objectives are maintained properly. So, in simple terms, infrastructure SLA mainly focuses on infrastructure services, while application SLA focuses on application level performance and service quality. This topic explains the important contractual elements of SLA. Infrastructure SLA and application SLA contain several key terms and conditions agreed upon between the service provider and the customer. For an infrastructure SLA, the agreement mainly focuses on infrastructure-related guarantees such as server availability, network connectivity, storage, backup, and system uptime. For an application SLA, the focus is more on application-level performance such as response time, application availability, workload handling, and quality of service. These contractual elements clearly define the responsibilities of the provider, the expected service level, monitoring conditions, and actions to be taken if service commitments are not satisfied. So, SLA helps establish clear expectations between cloud providers and customers regarding service quality and performance. Steps in SLA lifecycle. The SLA lifecycle consists of several steps followed between the organization and the cloud service provider. The first step is discover service provider. Here, the organization identifies a cloud provider capable of meeting its service requirements. The next step is define SLA. In this stage, service level requirements such as performance, availability, and response time are clearly defined and agreed upon. After that comes establish agreement. A formal agreement is created between the customer and the service provider specifying all terms and conditions. The next step is monitor SLA violations. The organization continuously monitors whether the provider is meeting the agreed service objectives. If the provider fails to satisfy the SLA conditions, The next step is enforce penalties for SLA violations. Penalties may include financial compensation, reduced service levels, or other corrective actions. Finally, if the service remains unsatisfactory, the SLA may be terminated. So, the SLA life cycle helps ensure that cloud services maintain the required performance and reliability standards. Service level agreements provide several advantages in cloud computing. One important advantage is improved communication. SLAs clearly define the expected level of service between the provider and the customer, improving understanding between both parties. Another advantage is increased accountability. The service provider becomes responsible for maintaining the agreed service standards. SLAs also provide better alignment with business goals because the required service levels are clearly specified according to organizational needs. Another important benefit is reduced downtime. SLAs define procedures for handling failures and service disruptions, helping minimize interruptions. They also support better cost management by clearly defining the services provided and the performance levels. So, overall, SLAs help improve service quality, accountability, communication, and operational reliability in cloud environments. Along with advantages, service level agreements also have certain disadvantages. One challenge is complexity. Creating, maintaining, and enforcing SLAs can become complicated and may require significant effort and resources. Another issue is rigidity. Sometimes SLAs may not be flexible enough to adapt to changing business requirements or service demands. SLAs can also lead to limited service options because the provider may only offer the services specifically mentioned in the agreement. Another disadvantage is misaligned incentives. In some cases, providers may focus only on meeting the minimum SLA requirements instead of improving the overall service quality. Finally, SLAs may involve limited liability. Even if service failures occur, the provider's responsibility may be limited according to the terms defined in the agreement. So, while SLAs improve service agreement, they also introduce challenges related to flexibility, complexity, and responsibility. Let us now discuss two open source cloud computing platforms, that is Eucalyptus and OpenNebula. Both platforms are mainly used for building and managing private cloud environments. First, Eucalyptus stands for Elastic Utility Computing Architecture for linking your programs to useful systems. It allows organizations to create private or hybrid cloud infrastructures within their own data centers. Eucalyptus supports the infrastructure as a service or IaaS model and helps manage virtualized resources such as virtual machines. An important feature of Eucalyptus is its compatibility with AWS, making migration between private and public cloud environments easier. The next platform is OpenNebula. OpenNebula is an open source toolkit used for managing virtualized data centers and cloud infrastructures. It supports private clouds, public clouds, and hybrid clouds. OpenNebula provides efficient management of virtual machines, storage, networking, and cloud resources. It also supports multiple hypervisors such as KVM, VMware, and Xen. So both Eucalyptus and OpenNebula help organizations create flexible and scalable cloud infrastructures using open source technologies. Let us now look at the Eucalyptus architecture in detail. The architecture explains how different components work together to provide a private cloud environment. At the top, users interact with the cloud through client interfaces and cloud management tools. These user requests are handled by the cloud controller, which acts as the central management component of the Eucalyptus cloud. The cloud controller manages resource allocation, user requests, networking, and overall cloud coordination. Below that, we have cluster controllers. Each cluster controller manages a group of computing resources inside a cluster. The cluster controller communicates with the cloud controller and helps distribute workloads efficiently. Next comes the node controller. Node controllers run on individual physical machines and are responsible for managing virtual machines on those systems. They start, stop, and monitor virtual machine instances. Storage services are also part of the architecture. Eucalyptus provides storage controllers and object storage services for managing cloud data and virtual machine storage. A simple way to understand this architecture is by comparing it to a university system. The cloud controller acts like the university administration office managing the entire university. The cluster controllers are similar to department heads managing different departments. The node controllers act like individual classrooms or laboratories where actual activities happen. Finally, the storage components function like the university library or storage rooms where data and resources are maintained. So all these components work together to create and manage a complete private cloud infrastructure. Next, moving on to OpenNebula. The architecture of OpenNebula explains how different components interact with each other. At the top, we have the local user and administrator interface. Through this interface, administrators and local users can create, manage, and monitor virtual machines. Next is the cloud user interface. This allows external users to access cloud services remotely and deploy virtual machines through the cloud. The scheduler is another important component. The scheduler decides where resources such as CPU, memory, and storage should be allocated for virtual machines. It helps distribute workloads efficiently across the cloud infrastructure. Then we have the cloud service component. This provides self-service cloud functionality where users can request and manage resources automatically. A simple way to understand this architecture is by comparing it to an airport system. The user interfaces are like passengers and staff interacting at booking counters. The scheduler acts like the airport control system, deciding which flight or gate should be assigned. The cloud service component works like the automated ticketing and service system that allows users to access services quickly. So these components together help users access and manage cloud resources efficiently. Continuing with the OpenNebula architecture, the central component here is the Virtual Infrastructure Manager. This component acts as the brain of the entire cloud system. It manages virtual machines, networking, storage, and overall cloud operations. Below that, we have components related to virtualization, storage, networking, and cloud integration. The virtualization layer manages hypervisors such as KVM, VMware, and LXC for running virtualization missions. The storage component manages disk images and data used by virtual machines. The network component handles IP addresses, virtual networks, and cloud connectivity. At the bottom, the diagram shows local infrastructure and public cloud. Local infrastructure refers to on-premise physical servers and resources. Public cloud represents external cloud providers such as Amazon Web Services or Google Cloud. OpenNebula can integrate both local infrastructure and public cloud resources to create hybrid cloud environments. Continuing the airport example, the virtual infrastructure manager acts like the airport control center managing all operations. Virtualization and storage components are like the runways, baggage systems, and communication networks. Local infrastructure is similar to the airport's own facilities, while the public cloud is like connecting with external airports and airline networks. So OpenNebula coordinates all these components to manage cloud infrastructure efficiently. With this, we come to the end of Unit 1 on Cloud Introduction and Cloud Infrastructure. In this part, we discussed major cloud platforms such as Amazon Web Services, Google Cloud, and Microsoft Azure, SLA and CLA concepts, energy impact of data centers, and open source cloud platforms like Eucalyptus and OpenNebula. Thank you.